Okay, so welcome back. Now, we're going to talk about diagonals and distance across flats. So distance across corners, which is the diagonal, and distance across flats. Okay, so what's the diagonal here that we're talking about? It would be the distance from one vertex straight across to the vertex, not to here. Even though that is a diagonal, we're talking about across from opposite vertices. Okay? So any one of these lines is a diagonal that we're interested in. So again, if you just think about it, it's easy to derive these formulas because we know that each triangle here is an equilateral triangle. So if this is A, that means all of these are A. And so then the distance across is going to be A plus A, which is 2A. And then of course you could just solve for A to get it in terms of the diagonal. So A is half of the diagonal. Now what about the cross the flats? Now this is a little bit more complicated, but you can still do it, right? So the flats are from the midpoint of one side, oops, to the midpoint of the other side. Okay, now remember, this is just the altitude, right? This is the height of the triangle. Well, we know how to get the height of the triangle by using the Pythagorean identity, and then it's just double it, right? So again, you could do that easily. Okay, I'm not going to do it, but just realize that the distance across flats, from this flat to this flat, or from this flat to this flat, or the other distance, is the same, obviously. But F, which represents that distance, is going to be 1.732 times A. Okay? And then of course you can always solve for A and then get it in terms of F. And that's it. So again, make sure you know these formulas, or you're able to derive them.